Hello everyone, this video is about solving trigonometric equations. So first of all, adjust the domain. Look at the angle here, 2x minus 30 degrees, but the domain is for x. So here we have to make this x somehow exactly the same as this. We can do that by multiplying throughout by x. We get 2x is between 0 and 720 degrees. We subtract 30 degrees, and now we get the 2x minus 30 degrees is between minus 30 degrees and 690 degrees. And here we have x plus pi over 3 all over 2, so we have to add pi over 3, and we get 1 over 2 plus 1 over 3, so 5 over 6. And if we add 3 over 2 plus 1 over 3, that would be 2 plus 9, 11 over 6. And then we divide by 2, so x plus pi over 3 all over 2 is therefore between 5 pi over 12 and 11 pi over 12. So that's called adjusting the domain so that it fits the angle we are working on. Next, find base angle. So to find base angle, we use the inverse of the positive value. So in this case, the base angle is inverse sine, because this is sine something, 1 over root 2. You don't use the negative. And here, if you use your calculator here, you will get something negative. This is something negative. Therefore, the base angle is inverse cos. Remember, we are using the positive value, so you can just say minus 3 minus root 8 all over root 2 minus 2, so that we get the base angle in quadrant 1. Next, finding corresponding angle. So let's say we know that sine x equals 1/2. We know the base angle is 30 degrees, and the domain is from 90 to 270 degrees. So if the base angle is 30 degrees, of course, the angle in the first quadrant is 30 degrees, in the second quadrant 180 minus, in the third quadrant 180 plus, and in the fourth quadrant 360 minus. Now, since the sine value is something positive, of course, we cannot use quadrant 3 or quadrant 4. Or if you're not sure, use your calculator. What do you get? Sine 30 degrees, what do you get? Sine 150, what do you get? Sine 210, sine 330. If you use your calculator, you will get negative, negative. So that's why we reject this. It's impossible, because we are looking for sine something equals positive 1 over 2. So the angle must be either 30 or 150. Now look at the domain from 90 to 270. Of course, this is not in the domain. So therefore, we have only one answer, 150 degrees. And now we have 60 degrees. So 60 degrees base angle means it could be 60, 120, 240, or 300. You can look at the domain first, maybe between 90 and 270. So 60 is impossible, 300 is impossible, not in the domain. Now look at the value of the sine. It's negative. In the second quadrant, it's positive. Or you can just use your calculator. What do you get from sine 120, and what do you get from sine 240 degrees? The only way you can get minus 3 over 2 is only by using 240 degrees. So this is impossible, because again, sine in the second quadrant is positive. And for the 45 degrees, same thing. Well, of course, now as you can see, domain is from 90 to 270. It is impossible to use 45. We can only use 135 second quadrant, or 225 in the third quadrant. You cannot even use the fourth quadrant, of course. but we need to get something negative. Which one will give us something negative? Just use your calculator. Which one will give you negative 1 over root 2? Remember, this is equal to minus root 2 over 2. And if you use your calculator, you will only get negative from quadrant 3. I mean, actually from both. So from both, you get negative. So we have two solutions here actually. And now from 30 degrees between 90 and 270, we cannot use the first quadrant. We can only use the second and the third quadrant. We cannot use 330 in the fourth quadrant, of course. It's not in the domain. So after that, we make sure we get negative. You can use your calculator. Tangent 150, you will get something negative. Tangent 210, you will get something positive. We are looking for negative, so only one solution. One more time, two more times. So here between minus 90 and 90, so we can only use 45 degrees or minus 45 degrees. The other angles are not in the domain, of course. Only two possibilities. We need to get something positive, so of course this is impossible. Only one solution. And now 60 degrees. 60 degrees in the third and the fourth quadrant. In the third quadrant, that's 240, and the fourth quadrant is 300 degrees. And we need to get something negative. That means we cannot use this because this is in the third quadrant. Tangent is positive. And after you get the angle using the inverse cos, remember that sometimes the angle we are dealing with is not just x, it can be 2x. So remember that we have to divide throughout by 2 in this case. That's the final answer. And here we have to subtract by 30 degrees. Okay, and here we have to add 30 degrees and then divide by 2 for the final answer. And here we have to subtract 10. Remember, we subtract, we don't add, of course. And here we multiply by 2, so we get the final answer. So for example here, we're not gonna prove the identity. Let's say we have proven the identity, so this is equal to this. That's why we are using the right hand side. And now we can, this is a fraction is equal to 0, the numerator is equal to 0, so we just use the denominator equals 0. We can divide throughout by 2. This 2 is not important. Tangent is sine over cos. We can multiply both sides by cos, so we get just sine. If you multiply by cos here, cos times this cancel out, we have only sine. Cos times cos, we get cos squared, so we have cos squared. And cos squared is 1 minus sine squared, Pythagorean, which means we have sine plus sine squared, or sine squared plus, this is sine squared first, sine squared plus sine minus 1. And from here we can use the quadratic formula. This is just like a squared plus a minus 1. We can get two solutions here, which means sine theta could be this or sine theta could be that, which is around here. Remember, sine cannot be more than minus 1, I mean smaller than minus 1, so this is impossible actually. But if you don't know that, just use your calculator, use inverse sine, you'll get an error. And here if you use inverse sine, you get the only solution. Last one, we're gonna start with the quadratic. This is just like the usual quadratic. Replace the cos with a, solve for a, so that means cos theta could be this or cos theta could be this. This is bigger than 1, so it's impossible for cos any angle to be bigger than 1. This is of course rejected. Or if you use your calculator here, you will get an error. And here if you use your calculator, you get the base angle, which is 78.6, but it says here the theta is between 0 and